All right, Algebra 2. Hey, gonna have to bear with me a little bit. I'm trying something out new. So if you guys could, we're gonna try something out here where I am recording a Google Meet meeting, and I'm just gonna see how this can work. And we're gonna do the best we can where I think this is gonna be helpful for the future, and just me getting used to using the iPad and Google Meets and all that fun stuff. So anyway, blah, blah, blah. All right. Hey, we are moving into chapter 13. All right. And we're going to be covering section 1 today. So you can see we're talking about right angles of trigonometry. And you should be on page 929 in the textbook. And something else I wanted to let you know based upon this chapter is we're only going to be doing the first 4 sections of this chapter. I think that's about all the time we're going to have to cover as far as sections in this chapter, and then get some time to review and then give you guys a little exam on those 4 sections. Okay, so again, we're going to do section 1 today. We're not going to go any further than section 4. And that's kind of the book's, like their version of saying you're halfway through the chapter. And then we'll do, one of those little mid-chapter things, and then more reviews from the back. Okay, so let's get right into it. You guys can see here my screen. And so again, you need to be on page 929. Copy all this info down. So right here, as it says, you're going to be copying the chart on page 929, trig functions. You're going to be copying the chart on page 930. That's, I believe, trigonometric ratios of special right triangles. Something that you should know is that symbol right there stands for theta, and basically just looks like a circle with a little line drawn through it going from left to right. And so those are the things at the beginning. Take care of that, copy those down, or at least know that we will be referencing those charts throughout the section, and you're going to need to know those charts or have them memorized or written down when it comes time for your test. All right, the next thing is I'm sure you've heard Sohcahtoa, and if you have not heard Sohcahtoa, well, welcome to Sohcahtoa. All right, so you guys are going to be given, mainly throughout this whole chapter, or at least this section, right triangles. And so right triangles, you can see, are triangles that have a 90-degree angle. There's your right angle. The side that is opposite of your 90-degree angle is called the hypotenuse. Okay, that is that guy right there, the hypotenuse. It's the longest side of a right triangle. And you may wonder, what is your starting point? Because they're going to ask you to solve for things. And as you can see with that point, theta is always your starting point. All right, now let's figure out what Sohcahtoa actually means. S stands for sine. O stands for opposite. And when I say opposite, I mean opposite of theta, because theta is your starting point. And H will always stand for hypotenuse. So if I were trying to figure out, I don't know, we can plug some values in here. Let's say theta is right there. And let's say we're just going to be labeling these A, B, and C. All right, if I was trying to figure out the sine of theta, then I would start at theta, and I would say, what is opposite of theta? Side B is opposite. And then you're going to divide that by the hypotenuse, which would be side C. All right, so for all of this, it's division. Okay, so opposite over hypotenuse would be sine. For cosine, again, you start at theta. A stands for adjacent. Adjacent's like just a fancy word for next to. Okay, and if again we're starting at theta, the next to theta side is A, and then you're going to divide that by the hypotenuse, which would be C. Okay, and then for tangent, it's opposite divided by adjacent. So in this case, it would be what is opposite theta, it's B, divided by what is next to or adjacent to theta, which is A. All right, you guys are going to see how that all plays out in example 1 right here. Okay, so in example 1, you're given the triangle, there's your right angle, you have a hypotenuse given, and you have a side given, and you can see theta right up there at the top. Okay, so they're going to want to figure out, as it says, let me get to the right page here. We want to know the sine, the cosine, and the tangent. Okay, and you always want to make sure that you reduce when you can in these fractions. All right, so let's see if we could. All right, get the pen working here. All right, so we're going to first figure out the sine, and we got to go opposite of theta. Opposite is 30. All right, so 30 is opposite of theta, and h is the hypotenuse, and in this triangle, that is 34. And if we reduce that down, let's see, that should be 15 over 17. All right, so that was for sine. That's the so part. And the ka, all right, for Sohcahtoa, that stands for cosine. We have adjacent. So what is the side adjacent or next to theta? This is going to be 16. All right. I know you may look at the triangle and say, well, isn't the hypotenuse next to it as well? Yeah, it is. But the hypotenuse is special. It is only the hypotenuse. It's never going to be considered the adjacent side. That's important to note. All right. So adjacent to theta is 16. And then hypotenuse 34. And then reduce that down, and it's 8 over 17. Okay, last one here is the toa. That's the tangent. All right, and tangent is the opposite, which is 30. And the adjacent, which is 16. And 30 over 16, that's going to reduce to 15 over 8. All right, so there's example 1. Let's see, we can scroll. All right, you can pause it, copy that down. All right, let's scroll. We're going to get into example 2 here. All right, so example 2. All right, so now we're looking at special right triangles. Special right triangles, you should be on page 930. That's going to be a 30, 60, 90 right triangle or a 45, 45, 90 right triangle. And in this case, you can see we are given 45 and 90. So that must mean that the other side is 45 as well. So we're looking at a 45, 45, 90. And they are going to say, okay, solve for the unknown side. That's x. You know every angle, and you know the hypotenuse. Okay? So if you look at your chart, the 45, 45, 90 chart, it's going to give you what the sine of 45 reduces to in terms of like a radical, and the cosine and the tangent. All right, so if we want to figure out how to get x in this case, basically we're going to be looking at this 45 right here. Okay, and that 45 that was given, if we look opposite to it, I see x. And then if we have the hypotenuse, I see 20. So what uses opposite and hypotenuse is sine. So we're going to say the sine of 45 will equal the opposite, which is x, divided by the hypotenuse, which is 20. But what is the sine of 45? Okay, take a look at the chart. The sine of 45 is radical 2 divided by 2. So we have a radical 2 divided by 2 equals x over 20. So we need to isolate x. We need to get rid of the 20. And basically that's just simple multiply by the denominator to get rid of the 20. And what you do to one side, you will, of course, always have to do to the other. So now you're looking at a 20 over 1. And don't worry about that radical 2. You're going to leave it as a radical 2, but you can reduce here. The 2 drops down to a 1, and the 20 will drop down to a 10. So let's make this look a little neater. You have 10 radical 2 equals x. Okay, so that is your example 2 problem. All right, now let's scroll here, take a look at example 3. And we are on page 931 now. Okay, so I'll read it out loud to you here. We have a skateboard ramp will have a height of 12 inches and an angle between the ramp and the ground will be 17 degrees. To the nearest inch, what will be the length L of the ramp? Okay, and my apologies. I'm going to grab my calculator real quick. If you don't have your graphing calculator, you should probably go get that right now. So go grab that. And we're back. All right, so you're going to need your graphing calculator. Everything all good here. But there's something you're going to want to check in your graphing calculator. The first thing you're going to want to do is turn it on, of course, and then push the button that says mode. This button is directly next to the second button. That's the yellow button. Okay, and you want to check that you are in degrees and not radians. So that is you going down to the third row where it's going to say radian and then degree. And you want to make sure that check that degree and not radians is highlighted. So if radians is highlighted, you need to move it to degree and then hit enter. Once you hit enter over degrees, you know that degrees is highlighted. Go second, quit, and now you're back into the home screen of the calculator because we're going to need that for this problem. Okay, so what we are looking at, you see the picture down here. We're going to try to figure out what is x. And you got to think to yourself again, are we using sine, cosine, or tangent? Well, if I look at the 17 degrees, I see something that is opposite of the 17. And then I see I'm looking for the hypotenuse, which is the unknown side. So again, what uses opposite and hypotenuse? That's the sine. So we have the sine of 17 equals 12 over x. Now, if you look back in the problem, they even use the phrase to the nearest inch because they acknowledge that you're going to actually have to plug into your calculator sine of 17. Okay, so now where are all of these like sine and cosine and tangent type things? So we're going to need to, let's see, push in, go to all right, so when you take a look on the calculator, you guys are going to be going directly to, it's about right in the middle. You're going to see sine, cosine, and tangent. And since we want the sine of 17, you're going to push sine and then plug in 1, 7, and maybe go ahead and finish out the parenthesis just in case, and hit enter, and I get a 0.292. So we have a 0.292 equals 12 over x. Go ahead and put that over 1. So now you're just looking at a proportion, okay? If you were to cross multiply here, you're going to get 12 equals 0.292x, and then both sides need to be divided by that 0.292. All right, and let's get our answer. So we're going to have 12 divided, and that gets you approximately 41. All right, approximately 41. Okay, so that covers example 3. And now we are looking at example 5. We're going to skip example 4. I got a little note right here on the screen for you. Cosecant is the exact same thing as basically the inverse sine. So in other words, if you were to calculate for sine, you're going to get a fraction, right? And then if you flip that fraction, now what you just created is the cosecant. If you calculate cosine, and then you get a fraction, flip that fraction, you now have the secant. And then do the same thing for tangent. Calculate tangent, get the fraction, flip it. That's now called your cotangent. All right, so let's remember that little note there, because now what example 5 tells us to do is solve for all 6. So start by solving for the sine, the cosine, and the tangent. Just like we did in example 1, you're then going to have 3 fractions. Flip each of those fractions, and then that'll give you your cosecant, your secant, and your cotangent. Okay, so let's go ahead and get those real quick here. So you see theta, you got the right angle, you have your hypotenuse. You'll notice that we really don't have the value for the hypotenuse yet, right? Okay, so how do you calculate the value of your hypotenuse? Well, now you got to think back to basic algebra, and that's going to be the a squared plus b squared equals c squared. Okay, Pythagorean theorem. So let's get the hypotenuse real quick. 18 squared plus 80 squared equals, in this case, c squared. All right, so let's work this out. You have 18 squared, you have 80 squared, 324. That looks like a 9. Sorry about that. So you have 324 plus 6,400 equals 6,724, but that's what c squared is. So you're going to have to take the square root of that, and that is exactly 82. So we know that the hypotenuse is actually 82. Okay, so all 3 values need to be in there for you to calculate sine, cosine, tangent, and then do all their inverses. All right, so let's take a look at theta. Let's get the sine. Sine is opposite over hypotenuse. So we have sine is going to be 80 over 82. Reduce that down, 40 over 41. Okay, now if you take a look, we can get now the cosecant. As long as you have sine, you can get the cosecant. All right, and the way that they do cosecant is that it is CSC. Just flip the fraction. So 41 over 40. All right, and that's going to give you the cosecant. Okay, and let's scroll, give ourselves a little bit more space here. Okay, let's get the cosine. And cosine is adjacent, which is 18, over hypotenuse, which is 82. All right, 18 over 82, reduce that down to 9 over 41. And then if we want the secant, you just flip it. Now 41 over 9 is the secant, and tangent is opposite, 80, over adjacent, which is 18, and reduce 80 over 18. Let's see. 40 over 9. All right. And then you're having to look one more thing, the cotangent. Flip it. 9 over 40. Okay, so there's all 6 trigonometric functions that they are looking for. Again, I know this was a little different. This is the first time I've tried this out, so you gotta hopefully show me a little bit of grace. I know that it's not perfect yet, but I'll keep practicing. We'll get there. And yeah, as always, miss you guys. And we'll see you in the next video.